Hello everyone, today we are going to focus on uniform circular motion and we are going to solve some questions. Let's start with the first question. In a space flight simulator, an astronaut is rotated horizontally at 20 revolutions per minute in a pod on the end of a radius arm of length 5 meters. The mass of the astronaut is 75 kilograms. A. Calculate the central force on the astronaut. B. Calculate the rotation rate in revolution per minute. That would give a simulated gravity of 3g. Let's start with the choice A or let's first write down the givens. 20 rpm means the frequency of the motion is 20 rpm and the radius is 5 meters and the mass of the astronaut is 75 kilograms. Let's assume that the astronaut rotates in this pod. This is the astronaut. Let's assume that it's 75 kilograms. It says an horizontal motion and the radius is 5 meters. And the frequency of rotation is 20 rpm. We know that angular motion, or in angular motion, the angular velocity is equal to 2 pi f. 2 pi times frequency, which implies that angular velocity is equal to 2 pi times. We need to convert the revolution per minute into radian per seconds. So it is 20 divided by 60 seconds. It is radian per second then. This will be equal to 2 pi times or 2 pi over 3 radian per seconds. This is the angular velocity of the astronaut. And using the centripetal formula of angular motion, F is equal to mass times angular velocity square times radius. This will be equal to 75 kilograms times angular velocity square 2 pi over 3 square times radius is 5. Then the force on the astronaut is 1643 newtons. It's a very big force indeed. Okay, let me write this part and solve the mass is equal to 75 kilogram. For choice B, if you consider the choice B, calculate the rotation rate in revolution per minute. That would give a simulated gravity of 3g. We know that force in angular motion, the centripetal force, is equal to m angular velocity square times r, which must be equal to mass times 3g. You can cancel this m with this one. Then it implies that angular velocity will be equal to square root 3g over r. And angular velocity will be equal to 3 times 10 divided by 5, which is equal to 2.45 radian per second. But the question says, calculate the rotation rate in revolution per minute. Let me change the color. In revolution per minute. Then angular velocity in revolution per minute will be equal to 2.45. Since one revolution is 2 pi, we are going to divide by 2 pi. And 1 minute is 60 seconds. And we need to multiply by 60. Then it will be equal to 23.4 revolution per minute. That's the answer. Now let's go to the next question. Question 2. A wet cloth of mass 50 grams rotates at 1200 revolutions per minute in a spin dryer drum of diameter 0.45 meter. Calculate the central force acting on the cloth. The mass of the cloth is 50 grams, which is equal to, we need to convert it into kilogram. 0.05 kilogram, and frequency is equal to 1200 revolutions per minute, and the diameter is 0.45. Since the diameter is 0.45, that means the radius is half of it, 0.225 meter. And the central force acting on the cloth will be equal to mass times angular velocity square times radius. Now we have to calculate first angular velocity. The angular velocity is equal to 2 pi times frequency. It will be equal to 2 pi times frequency is 1200 revolution per minute. We have to convert it into radian per second. Then it's 1200 divided by 60. Then angular velocity will be equal to 125.6 radian per second. Now let's use it in the force formula. Then it will be equal to mass is 0.05 kilogram times angular velocity is 125.6 square times radius is 0.225 meters. Then the force will be equal to 177 Newton. That's the answer. That's the force acting on the cloth. Now let's go to the next question. Question 3. The figure shows a block of mass m moving without friction along 3 tracks with same speed v. Choose the correct alternatives. In the first case, the block moves on a horizontal surface with velocity v and mass m. The vertical or the normal force is N1. In this case, the gravitational force mg is equal to N1, isn't it? In the second case, the mass m makes an circular motion, so there is a centripetal force in this direction, which is equal to m velocity square over r, and also there is a gravitational force in this direction, which is mg. In this case, N2 is equal to mg minus m v square over r. In the second case also it makes an circular motion. There is an gravitational force of mg and plus a centripetal force of m v square over r. If we check the options, it says N1 is greater than N2. Yes, that's true. Choice A is true. N1 is greater than N2. This is N1, this is N2. And B, choice B, N2 is greater than N3. N2 is not greater than N3. This is false. C, N3 is greater than N1. N3 is greater than N1. Yes, that's true. Choice C is also true. And D, N1 is equal to N2 equal to N3. No, this is false. I hope it's clear. Now let's go to the next question. Question 4. How long will it take a race car to complete a turn in a curve with a radius of 450 meters if its centripetal acceleration is 22 meters per second square? Let's assume that this is the car. Let's assume that it's car. This is the curve with a radius of 450 meters. So r is equal to 450 meters. And the acceleration is equal to, centripetal acceleration is equal to 22 meters per second square. How long will it take a race car to complete a turn? It asks for the period of the car. One period of the car. We know that the acceleration, centripetal acceleration, is equal to v square over r, which implies that velocity is equal to root of acceleration times radius. Then velocity is equal to root of 22 times the radius is 450 meters. It is equal to 99.5 meter per second. Therefore, time t to go around the circle is 2 pi r over velocity. It is equal to 2 pi times 450 divided by 99.5, it is equal to 28.4 seconds. That's the answer. That's the period of the car also.